on to ocean renewable energy. This slide is originally prepared by Professor Pilsung Lee because there has been a educational project for 5 years in ocean system engineering, and that through that project and education program, this one is prepared. So I'm modifying a little bit from Professor Pilsung Lee's material. Right, and today we will cover the part 1, focusing on wind energy and tidal energy and wave energy. And renewable energy, by definition from Wikipedia, is coming from natural energy. Right? Natural energy, something like sun, wind, rain, and tide, and waves, and geothermal heat. So this is another picture image shows the definition of renewable energy. Most of the energy is coming from sun. We can use sun energy for the future of our globe. And solar radiation is very big. And wave radiation, hydrological cycle, and wind wave, and convection, and ocean tide is over here, and then in rocks and water, hydroelectric power, water energy, and also volcano is there. So mostly coming from solar energy. And the wind energy itself is also coming from sun's radiation. Big energy. And this is a byproduct of solar energy. Only 2% of the sun's energy is reaching the earth by wind energy. And we are collecting a little bit of wind energy. So that's very big. So heating near the equatorial line is making the air is going up and flowing in the other direction. That gives you a circulation of wind, right? Starting of wind, and polar and something. Right? So heating goes up the airs and going down and cooling down. That is the start of circulation. And this is the size-wise energy amount coming from sun. And 2%, they say, so converted into wind, and less is going to geothermal. And this is a total energy we are consuming by human, global consumption of energy. So still, we have enough energy coming from sun, even though we are concerning about energy consumption rate increase rate. So we need more technology to convert solar energy to our usage somehow. Wind energy around the Korean Peninsula. Here is the Korea's peninsula here, and here is Japan and China. You can see the red part is high energy, speed of wind, so that the wind around land side or around Korean Peninsula is not so high comparing to It's something different. I guess this one is very low, but my understanding is this should be higher region of wind. Probably that is because of the January something. We need to have a average around the year. So this is more typical to my understanding. So that the region around Jeju Island and also the southeast corner of Korean Peninsula is good region for wind power system. So that you can expect that around Japan is good for wind energy, comparing better than Korean Peninsula. This is a picture coming from, I guess, it's Jeju Island. There is a wind energy farm and park, and this picture is coming from several years ago, where there are 15 small units coming from Vestas. Vestas is a company from Denmark. And Daegwallyeong is a mountainside of Korean Peninsula around here. Daegwallyeong is. Yeah. But see that Jeju Island is good for wind power system. And why we are learning and using wind power? Because this is the low priced renewable energy up to now. Until today, the technology is saying that the price per watt or energy is lower. For comparing to sun or solar or wave or other current, wind is economical. Right? The trend of wind turbine is going to lightweight. It is going to any technology. They want to be more light, lower solidity, flexibility, but the apparent trend in wind turbine is larger diameter, bigger, right? And that gives you higher tip speed. Same RPM, but with a larger diameter, the tip speed is going higher, right? Same RPM, right? Tip speed higher. So now they are saying current model of big wind power system, the tip speed is higher than Maha, sound speed, right? You can calculate. Yes. So this is coming together, right? Coming together. And passive load relief. Something happening, the blade can break when there is a big high or shock waves of wind, right? And that can be usually in old days controlled by motor to change the angle of attack, right? But nowadays they make some special material, flexible material or geometry that gives you passive change of angle, right? By using a twist or flap, or we could say a British blade, something like that, bend and twist coupled blade. So when the wind is higher, that gives more twist or bend, so that angle of attack is reduced naturally, right? Passively, not active control, passive control. Or skew. Skew is a shape of propeller like this one. This we call shape. Skewed propeller. Skewed propeller. Right? Skewed. This gives you skew. Right? Skew propeller. And that is also you can find from a propeller of submarine. That gives you lower noise coming from propeller. And similar idea coming. And stability is also important.
You know what happened in North America in 2004? There's like a drop in the energy supply.
Right. I don't know the idea why it's coming short. Probably there can be some change in subsidiary money or political or administrative. I don't know. But because renewable energy is all of them are supported by governmental support. Otherwise, you cannot compete with the energy coming from other sources. So that is more political reason. There is some political reasons coming together, but there are maybe. Well, this is also all the statistics data. 10 years ago, we should have upgrade. And what is this? Ceramic, metal, wood, and what is this? Young's modulus. Okay, density. This is typical materials for any structure. Okay, how does the wind turbine works? It comes from wind, right? Inflow wind that makes the blade rotating, right? Rotating. So we call it a rotor, and blade makes rotor is rotation, and gives you rotor blade spin the main shaft and gearbox, and makes the RPM increase by gearbox, gives you a generator, and make electricity, right? Electrical output. Very simple. And then you need to transfer the electricity into grid, right? Grid. But there should be some upgrade of voltage, and also sometimes frequency should be changed, right? That gives you several processes, and also smart grid, because the wind blows, there is a fluctuation, variations, right? So energy generation is fluctuating too. Comparing to nuclear power plant or coal or oil-based, the generation is steady, right? Comparing to wind power is very fluctuating. And also, when we need electricity, we need to produce, right? But it is not, the fluctuation is up to the nature, so that you need to have a storage or conversion, the other thing. So it's not simple. And orientation, the axis of rotation. This is a vertical axis. It's not typical, not famous nowadays. Nowadays, most of them is in terms of horizontal axis. Right? But as system goes bigger and bigger, so now the size of blade is bigger than 50 meter, one blade. Then total diameter is more than 100 meter, very big. So that the top side weight is becoming bigger. So that this is not a good in terms of structure. Right? This is maybe better for structure wise, for big size, but efficiency wise, this one is still good efficiency. But the other things, we have some advantage there. So still they are competing each other. And size of wind, there's a trend as you see that years goes on, and then it goes up in size. And this one gives you diameter of 180 meter. 180 meter, pretty big. Currently, probably 2 megawatt is in the market, the popular market, 2 megawatt. But still it's big, right? 80 meter diameter. Right? So it's not good for land side one, because there are people nearby, townhouse, so that noise is coming, and also area is coverage is bigger. And also wind quality, wind speed is not so good in land side. So more and more is going to the seaside. So offshore wind farm is becoming more popular in these days because of the size increase. Because the wind quality is good for ocean. So that is also a trend. Right? Size of wind turbines, this is very small one, right? But for only one home, house or farms far away, or remote site, because we cannot make a economical connection to grid, electrical grid, very remote island, something. Right? That place is good, right? Intermediate, village, several houses, hybrid system with oil-based diesel engine or distributed power. But nowadays, more and more is going for bigger and bigger station, wind farms, and distribution. Good. Question? No question. Then we go on to next.
Sorry about that. Okay, so I'm going to mainly focus on, after the wind energy, I'm going to focus on the sea energy. So it's what about tidal energy or waves energy generation. So I'm going to begin with the tidal energy, which is the energy due to the moon. You know that the moon applies some like attraction to the waters on planet Earth, and it makes the water move, going on and come by. So the tidal energy are mainly focused on the shores from west and east. The bays have to be open so that the current can go on and go back. This is a really known phenomenon. We know how to quantify it, and we know when it happens. So you can easily find the hours of the tides due to some buoy on the open seas. We can just communicate when the tide is coming out. So here is some technology using this tidal energy. So the most famous and the most efficient is a tidal barrage, which is basically a wall into the water with a small hole in it and a turbine, which allows the water to go back, to come by and make the mill turn. And then when the water goes out, it turns the opposite sense. There's also this kind of in the water mills, so like the windmills, but in the water, oscillating. I'm gonna go fast on it because I have a video showing this. So this is a tidal barrage. You can see that it's by simple equation you can easily find the output, the energy you can have. But still, this energy is quite hard to use because it's only twice a day, so it's not really matching the consumption from the shores and from the people, because it's really not constant during the day. Okay. So maybe I can show you the video. Okay, there's no sound. Anyway, so okay, so this sums up what I said. The sun is applying some strength on the earth. The tidal energy is mainly on the coast. So this is really interesting because the energy is only sufficient if there's 5-meter difference between the high tide and the low tide. This sums up all the technologies. So there's a tidal barrage, I already told you, the tidal fence. So the tidal barrage is working like a dam, with the flow going out and going in and going out, and energy generated. So the tidal fence is some kind of turbine also, different shape. You have to know that the tidal barrage is the most efficient. So it's relied on generator. Sorry for no sound, but trying to catch up as I can. So the density of water is obviously bigger than the air, so it's more efficient. So it's actually a green, like an eco-friendly energy, and then it's like really predictable. And I just wanted to show you the technologies. Okay, going back to the presentation. Okay, so now let's go on actual plants. So here I found 4 plants on the planet, in France, Canada, and China, and 1 in Korea, which is like the most powerful one. It's already implanted and showing great results in Siwa. I don't know exactly where it is, but still in South Korea. Maybe you know about it. So it's a dam. It doesn't have to interfere on the flow of the boats. Here we have to talk about the wave energy. So this is some kind of technology which is floating. The tidal energy is using the current, so it's underwater. Here it's like floating, so using the surface energy. And by successive pistons, it's compressing water and making energy. The same system can be viewed here with a huge pump, like pumping the water and so producing energy with some kind of buoy, converting the wave power. Same here. Basically, you have a big wall and a big piston, and so the piston is resisting and compressing the water, and there's a hydroelectric plant on the shore. It's basically always the same technology but applied on different geometries. Here it's some project that just failed, unfortunately, but the idea was great. Many buoy. Here some buoy too, from vertical motion. Here some kind of innovative concept. So the waves are just filling a reservoir, which is then unfilled by the leak where the turbine is. So quite innovative, but it's not really efficient because you need a lot of space, and the dam is far better efficiency. And here the same that wave generation, but instead of pumping water, you pump air basically. So you have a generator, and this is called the water column, oscillating water column. Yeah. So this is all about the water and the waves and tidal energy. I'm sorry I couldn't show you the video. I don't know why, but anyway, I tried to explain it by myself. I hope you understood it well. If you have any questions about tidal energy or waves energy, feel free to ask. This is actually a technology we will use in our project, and in our project you will see what we chose. Any question about this huge source of energy, which is the sea? Okay, thank you.
Okay, then I am moderating this discussion today about the renewable plants, and actually this is kind of very in this issue we have very much plans also for issues to discuss. So That's why I am bringing here very essential and basic but very profound issues, both two issues. The first one is this: renewable plants can be the main energy source to humankind in terms of the effects on Earth. What I think is that if we use renewable plant as the main source, then there might be also some troubles that makes hard to use it as a main sources. So I want to make a debate. So which one of you are agreeing me it can be used as a main source? Agree?
I agree.
Yeah, one. And others disagree? Disagree, please raise your hand.
What do you mean by main energy? Like you were talking about like the drawbacks it can bring if we use only this energy.
Maybe saying like the portion is similar with the petroleum we are now using.
Okay, so you mean like using mainly
main sources, yeah.
Like your question is about, is it sufficient enough to fill all our needs, or what kind of drawbacks can it like?
That is also one of my points. Can we use it? Because it may not have. Yeah, and also there may be another problems. For example, what I think is that, for example, tidal energy or something, it is basically interrupting the flow of nature, right? Energy flow of nature. So if we interrupt it, it may harm Earth, or it may be harmful to human. So one agree and disagree.
So basically, you ask us to act like non-scientists because we don't know the drawbacks. We cannot quantify it yet. So we can just say, oh, maybe it can affect the nature. I can do that if you want.
But
I can disagree.
Using the fossil fuel, we are already contributing to make damage to the nature. So
like I said,
we have nothing to lose.
Yeah, but like I said, it's like I can disagree. Just saying like, okay, maybe it will affect, but I don't know in what way. I don't know. Maybe using the tidal energy too much will affect the current. Yeah, but it's not really scientific.
That's very good.
I can do this point of view if you want. I can find many arguments saying like if we use too much the current, maybe the sea life and the whales migration will be affected, so that the plankton will die, and then since all the animal life is
that's very. I think that's a very good point. Then why don't we use the material we learned previously for what professor lectured about? We can use that as a source of our discussion. So, no debate.
Agree.
Yeah, 2 agree and 3 disagree.
No, I agree.
Why do you think it? Why do you agree?
I think it's the future because we have to carry about the global warming, and with renewable sources we don't contribute to the global warming, at least when we use it, because when we build it and manufacture them, we are still using an electricity made from fossil fuel. So when we produce solar cell or wind turbine, we are emitting carbon dioxide because we are using the electricity that comes from fossil fuel. But if you never start to use renewable sources, we never arrive to a situation in which we have only renewable sources. So I think that we have to invest a lot of money and time and everything we have to renewable sources because it's the future of our project.
Okay, thank you. So what you mentioned is that whatever the danger factor is, it is a possibility, right?
Yeah.
Okay, thank you. Any counter arguments?
Okay, so I just definitely disagree, but I think it's kind of a paradox. Nowadays, in order to produce renewable plants and to use renewable energy, we use fossil energy. So it's like producing something supposed to be green with something what is not green. And so I hope that one day we will switch to all renewable paradigm, like using renewable plants to make over renewable plants. But I don't really think it's possible. Like, it's, you know, coming from huge energy. For example, if we take only the constant factor, like the fact that an energy, like most of renewable energy on a constant of time, like we saw it for tidal, for even for solar, for wind, it's not constant. So it's like every time you want to think about having a huge amount of energy from renewable plants, you have still this constant effect coming back to your face and saying like, no, you can't just only focus on that. So I hope, but I don't think it will be soon, at least not soon.
Okay, not soon. Okay, thank you. And 아까 손 드시지 않았나요? 예. Can you say the reason why you agree?
Someday, most of energy will be generated from solar energy because the quantity of solar energy is much more higher than any other source. So the harder is the technique. The power density is lower than any other technique. So I think if there is enough technique to get some energy from renewable source, then definitely all of the energy will be replaced by renewable energy.
Okay, thank you. And any other counter arguments? If there's no arguments, then let's go.
Maybe the only disadvantage is that you need a lot of space.
Yes, space.
So maybe you will have some problem with the panorama because you will ruin the panorama if you use wind turbine solar cell. A lot of ground will be covered by solar cell. Maybe not everyone likes to see solar cell instead of field.
Yeah, actually, that's what I'm thinking of. You know, I cannot imagine the Earth covered with solar cells is only a picture in Star Wars, not ours. I don't want it so.
I change slide and I say, have you heard about the shale gas?
What is that?
Shale gas. Shale gas.
Yeah.
You know, it's nowadays considered as a fossil fuel, so it's part of the fossil fuel. And to extract this gas is basically a gas which is like prisoned in the earth, like deep in the earth.
Yeah.
And so to extract it, you just drill, and you just push water, like you provide water with high pressure, so that it can like infiltrate in the earth and make the gas go to the surface. But there are so many drawbacks on the landscape. For example, when the gas like just come to the surface, it often cracks on the ground, so it totally like ruin all the landscapes. So if you're afraid of loss of beauty of landscape due to renewable energy, I can tell you that nowadays from fossil fuels you have also some landscape issue. I don't mean that it's the same level, but still using only fossil fuel also affects the landscape.
Okay, thank you. I think that's very good point. And any additional comments or idea or data? Okay, then let's go to the next topic. So now you are Ocean Renewable Energy. It's a very long plant company owner. You are CEO of the Ocean Renewable Energy plant, and the company deals with worldwide customers. So my question is, what is the most important factor in your business model in terms of the worldwide customers? I actually made this question because what I first think is that the ocean energy plant is not like an iPhone. We cannot make only one product and sell it worldwide. So we are basically facing so many unexpected conditions and constraints something. So in that sense, what can be the most important factor to make business profitable or to make safe or something?
It's beautiful numbers for the politics. I tell them, like, yeah, take my power plant, I sell it to you, and then you can just show your people and all your nation how good are the renewable energy in your country. You'll be the first leader in renewable energy with my power plant. I guess nowadays people, it's not really about economical aspects, it's mainly about like how beautiful is it from the outside. Like it's all matter of politics, I guess.
Okay, thank you. So what you mentioned is the rhetorics, right?
Yeah.
Kind of rhetorics to make it sell. Okay.
I think it's unfortunate, but I think it's how it works now.
Then what about engineering aspects to make a product? Okay, what is the most important?
The product should be as efficient as possible.
Efficiency.
The most important factor is the efficiency.
Efficiency.
I mean, you have to reach the high energy you can. So this is the most important factor by an engineering point of view.
So in terms of cost?
Yeah. I mean, the higher the efficiency, the more energy you get with the same amount of money and power that come from the sun. So you will save money and you will have more energy. So I think that the most important factor is the efficiency of the plant.
Okay, thank you. And then another ideas? Any?
Actually, I think that the efficiency is obviously one of the big matter or topic. But like since the renewable energy, like the wind, for example, is supposed to be free.
Yeah.
So you don't like from an engineering point of view. Of course, you care about the yield and how many energy you can produce from an input of energy. Like the transition between the two is obviously very important for an engineer. But like outside the engineer, since the energy, the wind is free, no one cares if you take more wind to produce same amount. Still, if you produce more, it will be better. Like so, the yield is important in an engineering point of view, but from the outer aspect, I think that the power of the mill is really important.
So then roughly summarizing that.
Yes, but to produce more power, you need more wind turbines, more space, more money.
Yeah.
So it's not. I mean, if you have the highest efficiency, you can get the same amount of power with less space,
No, but
and less money.
Like if you have a bigger windmill with a lighter yield rather than a smaller mill with higher yield, people will not care. Like they will
I
take
think they care about the space you occupy with your
on the sea. No. Maybe
I don't know. It depends where is the plant. If it's in the middle of the sea, okay, no one cares.
Sure.
But I think that everyone cares because there are some environmentalists.
Yeah. I don't know. One day maybe we'll see.
Okay, then any other comments? Any other ideas or counter arguments? All right, then let's end it here. And yeah, thank you for your discussion.